Namaste student. Today we are going to do range of real function. So let's try to understand. Take the function. Suppose we are taking a function f a to a. Here we are taking both the functions, both the set same. So let us assume a will be what 1, 2, 3, 4 finite set. So here 1, 2, 3, 4, 1, 2, 3, 4. Now assume that 1 map to 1, 2 map to 1, 3 map to 2, and 4 map to 2. So what you can find here that this first one set is called what's a domain. Second one we call codomain, and the part which have the image pre-image, remember we call like that 1 map to 1, 2 map to 1, or we can say that image of 1 is 1, image of 2 is 1, image of 3 is 2, image of 4 is 2. And if I want to say that pre-image of 1 is 1 and 2, pre-image of 2 is 3 and 4. So here range would be what's the domain will be 1, 2, 3, 4, and here the domain is 1, 2, 3, 4. Both the domain and codomain are same here, but you can see that range means what's the output of the function. This is your function, we have defined such a way we are getting this. That means range will be what's the output. If I take here value, like give the example also. Now we have here the range is 1 and 2. That is a different from your codomain. Sometimes codomain and range are equal also. So what is that, sir? If you take input means whatever value. Suppose you are taking 1, 2, 3 like that value, and you are giving a name of the function, that is fx equals to x square. Okay, the function name is fx equals to x square. Then the output would be for this particular value would be what, sir? That is 1 square, that is 1, 2 square, that is 4, 3 square is 9. These are the output. Okay, so what is the definition of the range? The range of a function refer to the set of all possible outcomes values or y values that the function can produce. Okay, so now we'll try to find the range of the function. To find the range of the function, we're going to see the algorithm. Okay, so we have here 4-step algorithm. So first one, what we're going to do, first one will label the function as what? First we'll label the function as y equals to fx. That is our first target. Suppose our function is suppose our function fx is what's the 3x square minus 5. This is our function. So first step we'll take it here. Let y equals to 3x square minus 5. That is our first step. Now second step would be what? Expressing this x as a function of y. Function of y. That means right now we have y in term of x. Our target to get x in term of y. Let's find it here. Y plus 5 divided by 3 equals to x square, and this gives us x equals to plus minus root over y plus 5 by 3. So we have here x in term of y. Okay, now the third step would be what? We'll try to find all the values of y that will make the function right now is what? Plus minus root over y plus 5 by 3. Okay, is what's a define. So our target to find all the values of y where f of y, we call this is f of y, is defined. Okay, see here, this is your f of x, this is f of x, this is in term of x, this is in term of y, so f of y we call. So what the third step would be what? Find all values of y, f of y, है ना? Find all values of y where f of y is defined. That is our third step. and we'll eliminate. The fourth step would be what? We will eliminate all those values which in which what we get, the function is undefined. So fourth step, what we're going to write: eliminate the values of y that will make the function undefined. So what you can find here for this question, square root, square root, this is your square root. Square root is defined for what's for non-negative values, as we are discussing about real function. So if the part, interior part of radical is negative, then this gives us imaginary number, and we need real numbers as it is a real function. So square is defined for what? Non-negative value. That means to get y value, y plus 5 by 3 must be greater than equals to 0. This implies y plus 5 must be greater than 0, as 3 will go this side into multiply here, or multiplying both side by 3 we'll get this y plus 5, and subtracting minus 5 from both side we'll get y greater than equals to minus 5. That means y belongs to, if we'll keep this one in interval, we may write, as we can see that there's equal to symbol. That means first infinity is there, greater than minus 5, so minus 5 to infinity. This will be in a semi-closed interval. Therefore these are the value of range. So therefore range of function is what, sir? Minus 5 to infinity. That is your range for this particular problem. So what we have done, first we have labeled the function as y equals to fx, then expressing y in term of x into x in term of y, and then we are trying to finding all the values of y for which f of y is defined, and we'll eliminate all those values that will make the function undefined. For what type of function? This is your function now. So this way we have to proceed. So let's take a few more problem and try to explore the meaning of this one. So for example, if we'll take a problem, so take one problem like function would be like this: fx equals to x square by 1 plus x square. This is your function, and question is find the value of, not find the value, find the range of this function. So you may find the domain also. Domain, for domain this should not be equals to 0, denominator should not be equals to, already we have discussed the domain topic in the previous video, so we'll not enter into this one. So directly we'll go for the range. For range, our first target, we'll label this one. So let y equals to x square by 1 plus x square. Next target, x in term of y. Right now we have y in term of x. We'll try to find it. Y into 1 y x square equals to x square. This gives us y, that is x square minus yx square, x square common, 1 minus y, the y by 1 minus y equals to x square. This we have, and this gives us x equals to plus minus root over y by 1 minus y. This is very interesting. I hope that you people know about how to solve the linear problem here. So after solving, we are getting this one, plus minus root over y by 1 minus y. As the first target, denominator should not be equals to 0, and the whole thing should not be less than 0, means negative should not be there. To get this one, so the function f of y is defined. F of y is defined if what, sir? If y must be greater than equals to 0 and 1 minus y should be greater than 0, not equals to 0. If this y 1 minus y become 0, then this will be undefined. And if y become 0, it is okay, no problem. But if y would be less than what we call less than 0, then this will be minus party will get here, minus will get minus minus plus, and the whole thing become a negative. So what we need to get, y must be greater than equals to 0 and this must be greater than 0, denominator should be greater than 0, and this imply that is what, that is y should be greater than equals to 0 and this 1 minus y is greater than equals to minus 1, and this imply y must be greater than 0, and if we multiply minus 1 on the both side, this symbol change give us the, we'll get here y should be less than 1. That means that is what, that is y should be greater than 0, that means greater than 0 but less than 1. This is your range, this is your range. Therefore range of function f of x we are getting here 0 to 1, semi closed interval, or you call semi open interval. Okay, this way. And let's see one more problem, we'll see, and we'll try to understand the meaning of range. Suppose we have take one more function, this time take the function fx equals to 2x minus 1 by x plus 4. This is your function. So to find the range, we'll label here y in term of x, 2x minus 1 by x plus 4, and our target to get x in term of y. So multiply here, cross multiply, y into x, yx, y into 4, 4y. This side we have 2x minus 1. Take the x part this side, and the y part this side. Yx minus 2x equals to minus 1 minus 4y. This give us y common, y minus 2, x would be common, and the minus also common here, 1 plus 4y. So next step, x equals to what? Minus of 1 plus 4y divided by y minus 2. If I take minus common from this side also, to minus minus cancel each other, we'll get 1 plus 4y divided by 2 minus y. So x in term of y we have. So to get this function defined, then what is our target? The f, we'll write here f of y is defined when if denominator, that is if 2 minus y should not be equals to what? 0. That is what, minus y should not be equals to minus 2, that is y should not be equals to 2, because if we substitute here 2 minus 2 will give us 0, and this become undefined. So therefore what we can write here, therefore range of function f would be what? All the real number except 2. So we may write the answer in this way, or you can keep this answer in interval form also. How, sir? So this minus 2 is not there, so minus infinity to 2, okay, open bracket, union 2 to plus infinity. This is the another presentation of this one, real number minus singleton set 2. Okay, that can be represented in a interval form also. So I hope it is clear to all of you. So now a few problems for you people, you try by yourself. Here you have a problem. So here we'll see all the problem one by one. Let's see. First one, I'll do in the short way. You have to do as the way I have done in the last previous 3 questions. The way, same way you have to proceed. Okay. So what you can see in the first one, that is root over 2 minus x. This is a function. So we'll write here, let, first one, let y equals to root over 2 minus x. Okay, so first our target to make x in term of y, so square it here, y square, taking square on both sides, 2 minus x, squaring on both sides. Okay, squaring on both sides. Now y square minus 2, or you take x this side, and y this side, you will get here 2 minus y square equals to x. This will be going to get. So what you can find from here, that we are getting, for all the real values of y, this function is defined. But we have to look at the domain also. We don't know about the domain now. So for this type of problem, first we have to know the domain also. So domain would be what? For domain, root over interior part, that is 2 minus x, should be what, sir? Should be greater than equals to 0. That means if I take here that one, this side minus x should be greater than minus 2, then is minus x should be less than equals to 2. That means function will be defined for what? That is x belongs to what? Minus infinity to 2. This one. That means x can be only from 2 to minus infinity. It cannot be more than that. For that, the lowest one would be what, sir? Here, what we can get, that this x would be what? You can take any values, but what, x is belongs to minus infinity to. If I take the minimum value for y equals to 2, if I'll choose, I'll get here what? X equals to what? 2 minus 2 square. I'll get here 2 minus 4, that is minus 2, and there is this side, correct? And if I'll choose here y value 0, 0, so what I'll get x equals to 2 minus 0 square, I'll get 2. So what you can find it here, that we can take any value of y and we'll get x defined in it. Yes, so f of y is defined for all y belongs to real number. Therefore, range of this function would be what? Real number. Now if you suppose take one more problem like root over x minus 1, this is your problem, suppose. So we'll take it here, y equals to this one. So what result we'll get for this type of problem? Let's see here. Previously it was root over 2 minus x. Now we have root over x minus 1. So what result we're going to get? We'll square it on the both sides. We'll get here y square equals to x minus 1. This gives us y square plus 1 equals to x. First, before solving this one range, we have to find the domain also. And for domain, what do we have? That x minus 1 should be greater than equals to 0. That means x should be greater than equals to 1. Okay, that means x must be belongs to what? 1 to infinity. That is your domain. So here, if I take y equals to 0, so what you can find that, actually one more thing is what, actually for this also, if you look at here, for all values you will get, now for all values the fx is defined for all real number, but okay, first we'll enter into this one. This whole thing would be positive, yes, and square root of any positive number will give us a positive only. That means this is already a positive value. That means for all real number it is exist, but this one if you look, then our range would not be this. Our range is not this one. That means our range would be what, sir? This one. Okay, positive including 0. So here the range would be what? 0 to infinity. You may say that, sir, why you have done here real number, hold the real number, but now you are writing here this one. What is the reason behind it? Because the reason is that this is square root of 2 minus x. Inside part must be, as it is a real function, then this inside part must be greater than 0. If it is greater than 0, then root over any positive number will always be a greater than 0 only. That means y cannot be negative. Then how could we take that negative values? That means the range would be what? 0 to infinity. Similarly for this one, if you look at here, what we are finding here, this x whatever value you will choose for y equals to minus 1, you will get here minus 1 whole square plus 1. The x would be here 2 only, which is in between 1 to infinity. If we choose here y equals to minus 2 also, or y equals to 2 also, what you can find here, x equals to what? 2 square plus 1 minus 2 square, that is 5. And here x equals to 2 square plus 1, also 5. But that means from here we can conclude that x should what, y should be what? All the real numbers. But from the beginning, what you can find, this y should be greater than 0. So two conditions we are getting from here. From this data, fy is defined and defined for all y belongs to real number, but y should be what? But y equals to what? Root over x minus 1, which should be greater than 0. So concluding this 2, we are getting here range should be what? Range should be, for this problem, the range would be what? If we'll substitute the value here, minimum value 0, if we'll substitute, so y should be minimum 0, so it will be your 0 and it will continue. You can take any value, check, that is greater than equals to 0, because if I'll take here 1 also, I'll get 0, and there will be no problem. It may be 0, may not be, so it should be greater than equals to 0. Yes, y should be greater than equals to 0, so our value can be 0 to infinity. That means range would be what? Range would be your 0 to infinity. Very interesting question, because sometimes we may get confused, and without the domain also we face the problem. Okay, so for some problems we have to look at the domain and then we have to enter into that. But if you have the concept of this one, then no need to solve this part. Directly you can solve it from here only. That from the first part, square root of any number, if it is in first positive, then it will be always positive. That means positive or equals to 0, it may be 0, because it is not in the denominator part. It is also not in the denominator part. But if I'll go this type of problem, what you can find here, y equals to 1 by root over what is there, x minus 5. So this gives us x minus 5. Achha, this is little different, because this should not be equals to 0. For domain, if you need to find domain, then you can easily find that this should not be equals to 0. Then for domain, let's check for this problem. For domain, what we have, x minus 1 should not be equals to 0. That means x should not be equals to 5. The domain would be what? All the real numbers except 5. Okay, this is a domain. Range will be what? Take this one this side, x y square minus 5y square equals to 1. X y square, take this one 1 plus 5 y square, x equals to 1 plus 5 y square by y square. Now this is your f of y. F of y is defined only when denominator should not be equals to 0. That means y square should not be equals to 0. That means y should not be equals to 0. Okay, for that, oh, we forget to tell one more thing, that here we have, if the question would be this one, then our domain would be this. Okay, but look at here, root over is there, root over. That means first condition, this should not be equals to 0, and the second condition is what, this part should be greater than 0, should be greater than 0. Which part, sir? X minus 5 should be greater than 0. You may write greater than equals to 0 also, but this is there and this one, so both included means x minus, if I give this one, then it would be what, greater than 0. If I have like this, I may say that x minus 5 greater than equals to 0. So combining of these two, we get x minus 5 should be greater than 0. That means x should be greater than 5. So our range, not our domain is wrong. So it will be what, sir? It will be greater than, that is 5 to infinity. That is our domain. Because if I think like this, then we'll get that one. But our function is root over is there, and this one in a denominator place. So see here, it was in a numerator place, so we have taken x minus 1 greater than equals to 0. As it is in a denominator place, so we'll choose here only greater than 0. So our data is 5 to infinity. This is our range. Now if you substitute any value of y, means y should not be 0 except 0, the range should be what? You take any value, it will always be what? If we'll take 0, it is undefined, but if we'll go for minus 1, minus 2, plus 1, 5, whatever, so our range would be what? All the values. Yes, we'll get all the values here. That means real number except 0. This is our range for this problem. So we may conclude this is our range, but again you see what, square root function, so this is wrong. So what will be that? 1 is already positive, so this must be positive, this whole thing must be positive. Numerator is already positive, this part will be positive. It cannot be what, sir? It cannot be 0. That means you cannot say here this is greater than equals to 0. So denominator cannot be 0. So it should be what? Greater than 0. So 0 cannot possible. So your range will be what, sir? Your range, as 0 is already excluded, so your range would be what? 0 to infinity. The range is 0 to infinity. You cannot take negative, as we'll never get a negative value. If we'll substitute here any value of x, which is greater than or equals to greater than 5, we'll get always positive. This will be positive, and numerator is already in positive form. That means y will always be in positive form. But if we look at this function says that range will be what? R2 whole R except 0. But if we again go for this one, what you can find that this is wrong. The range would be 0 to infinity. Very interesting. Without getting the concept of square root, you cannot get direct answer here. Remember this part. Okay, now we'll see this problem. So let's check here, let's solve somewhere else. So let y equals to what? X square minus 1 by x square plus 1. So for this function, you can see that denominator is already in positive. The domain can be any real numbers, as there is no restriction for this, because whatever value you choose for x, it will always give you positive, because square of any negative or positive number always give you positive. Positive plus positive will give you positive. No need to worry for that part. If negative, we'll get negative. If there is a positive, we'll get positive. So all whole real number values we may get for domain. Okay, Now to get range, first we'll label it like this, and then take the linear part, y x square plus y equals to x square minus 1. Then this go the side, y square minus x square plus 1 plus y equals to 0. This gives us x square common, y minus 1 x square plus 1 plus y. We have this one, this gives us 0. That means x square equals to what? We'll get here. Acha, this we have. So take that side. The whole part 1 plus y would be there. This will be in the denominator place. Y minus 1. Take minus common. So minus minus cancel each other. 1 plus y divided by 1 minus y. X square we are getting. X equals to plus minus root over 1 plus y by 1 minus y. Okay. So now we have to think it on this problem. 1 plus y by 1 minus y. So this interior part should be greater than equals to 0. So what we can conclude here, that 1 plus y by 1 minus y should be greater than 0. F of y is defined if this. That means to get this one, 1 plus y should be greater than equals to 0. And what? This should be greater than equals to 0. It may be 0, no problem. Denominator become a 0, no problem. We'll get the 0. And 0 root over 0 will give us finite value, no problem. And divided by 1 minus y. This should be what's greater than 0. Why? Because this part become a 0. This part less than 0 or equals to 0. If I'll take here equals to 0, then this will be undefined. So denominator should be greater than 0 and numerator should be greater than equals to 0. So from this to what we can conclude here, y should be greater than equals to minus 1. We'll take this minus that side, and this one minus y greater than minus 1, and multiplying minus on both sides we'll get y less than minus minus cancel 1. So what we are getting here, y should be greater than equals to minus 1 and y should be less than 1. That means y is belongs to minus 1 to 1 semi closed interval. Therefore range for this function is what? Minus 1 to 1. So you have to solve this way. Okay, we'll enter into the next problem. Let's see. So this is one more difficult problem. We'll take this one, we'll check how to solve it. Okay, and then we'll conclude the video. Let us assume that y equals to x by x square minus 3x plus 2. This gives us yx square minus 3yx plus 2y equals to x. Yx square, this minus will this side, minus 3yx minus x plus 2y equals to 0. This gives us yx square, this minus 3y minus 1, we'll take x common here, plus 2y equals to 0. So what you can find here, quadratic equation of x. So x will be what? You remember, if there is a ax square plus bx plus c equals to 0, by quadratic formula we can apply here, minus b plus minus root over b square minus 4ac by 2a. That means this should be greater than 0. Discriminant should be greater than 0 to get real value. Yes, our target that this part should be greater than or equals to 0. Okay, as it is in the numerator place, so greater than equals to 0, and if it is in, it will be in the denominator place only greater than 0. So this is our B, this is our A, and this is our C. So B means plus minus minus 3y minus 1 plus minus, and then plus minus root over B square, that is minus 3y minus 1 ka whole square, minus 4 into A is y, and C is what, 2y, divided by 2a, 2 into y. So from the denominator part we can conclude that y should not be equals to 0. As we are getting numerator part always greater than equals to 0, but due to this one we are getting condition, this one what we condition get we here, minus 3y minus 1 whole square minus 4 means 8 y square should be greater than equals to 0. Okay, so here we have, so you take minus minus common here, keep it safe. Let's solve it here. Minus minus common, 3y plus 1 ka whole square minus 8 8 8 8 8 2 root 2 y ka whole square. Why are we writing like this? Because a square minus b square will use this concept. Let's try here. A plus b, another a minus b should be greater than 0. That means 3y plus 1 plus 2 root 2y greater than 0, or 3y plus 1 minus 2 root 2y greater than equals to 0. This imply you take y common, 3 plus 2 root 2 of y plus 1 greater than equals to 0. This gives us, this one go that side, we'll get here y equals to greater than equals to minus 1, and denominator part would be this 3 plus 2 root 2. Okay, this will get here, this minus 1 will get this our result. And for this what we're going to get here, y common, take common y, 3 minus 2 root 2 of y plus 1 greater than equals to 0. This one will take that side, 3 minus 2 root 2 is greater than equals to minus 1. Now you take minus 1 common, because this is your answer, this is 2 into 1.4, so 2 into 1.4 you will get here 2.8. yes, very close to this one. So this gives us y is greater than equals to minus 1, 3 minus 2 root 2. So here or will be there, and the or, see here, if I take here y greater than equals to minus 5 and the y greater than equals to minus 2, and there is a or symbol, then if I'll take this part, automatically this part will come. Why? Because in the number line, if we take here minus 2 here, minus 3, minus 4 and minus 5, greater than minus 5 included, greater than equals to 5, and there is a or symbol. So either this or that, that means we'll get here range, and this is smaller. Why, sir? Because this give us, if we'll take here 1.4 into 2, we'll get 2.8. 3 minus 2.8, it gives us positive only, positive, and there is a minus negative, it will give us negative. And denominator will be what, sir? Little smaller in size. If denominator is smaller, then the whole thing will become a bigger. Yes, so here we have, so our range will be what? Therefore range will be this greater than equals to, that means minus 1, 3 plus 2 root 2 to infinity. This will be your range. Okay, I have a little doubt in this answer. Kindly find the reference book for this answer. Till then, goodbye. Thank you.